All right, so we're going to review what we know in Unit 4 so far. We're not done with this unit, but we are having a test on Friday to test you what you should know at this point. Just to remind you guys that the questions in this review are super similar to the questions you're going to see tomorrow. The setup is very similar. The way the questions are asked are very similar. So if you really listen to this and practice on your own, maybe once we finish, you're going to be in good shape. All right, in Canvas, I uploaded a blank copy of this review, so if you want to work through it with me right now in the video, that's a great idea, and then maybe print out a new one and try it on your own before tomorrow if you really want to, get a 100, honestly, okay? All right, number one. A research lab is observing the growth of a new strain of MRSA in an agar dish. I don't know how to say that. The initial area occupied by the bacteria is 2 square millimeters. In previous experiments with MRSA, scientists observed the bacteria to increase by 20% each week. Use the following graph comparing weeks to area growth to answer the questions. So this question has 3 main parts. You need to know the form, the direction, and the strength of the graph. All right, so the form, when we did this in class, we really kind of focused on, is it linear or nonlinear? Well, if it's growing by 20% each week, even though the data kind of looks like, it's kind of linear, you should know that this data is exponential, okay? You should know that this data is exponential, all right? You could also say nonlinear, or if you really thought it was linear, as long as you maybe draw a line through the best points, you can get some credit there too, right? But the best answer is exponential or nonlinear, right? And we know that because you are given a little bit of a background on what's happening here. Okay, direction is positive or negative. That's it. If it's increasing from left to right, it's positive. If it had been decreasing from left to right, it would have been negative. So in this case, the direction is positive. And finally, what is the strength? If you said it was linear, then you have to tell me the strength is, fairly good or some kind of qualifier there. Because we know the data is exponential, I'm going to say that the data is strongly exponential, right? That strongly resembles an exponential growth. So I'm going to say strong exponential. All right, strong exponential strength. Does this sound like a cause and effect relationship, or is it just a matter of an association between the variables, and why? Guys, tell us why, because even if you tell us an answer that we wouldn't have said, like maybe you say cause and effect, but we say just association, if you tell us your reasoning behind it, you can still get potentially full credit as long as your reasons are good. So I'm going to say it's just an association because I don't know what's causing the bacteria to grow. I just observe that it's growing over time. So I'm going to say I don't know the cause. Okay, I don't know the cause, so I can't say for sure that time is what is making this bacteria grow. All right, that's the whole first question, you guys. I believe this question is worth 10 points on the test. All right, let's go ahead and look at question number 2. Question number 2, you're answering these 5 main questions here after you complete the chart here on the left side. So we're given 4 pieces of data, right? The initial amount, the first term, second term, third term. And we're calculating the first differences and the successive ratios. First thing we're going to do for first difference is we are going to subtract, okay, we're going to subtract 7.2 minus 4, all right, and 7.2 minus 4 is just 3, right? I'm going to double check that. Got 7.2 minus 4, right, and we just get 3.2. It's late, sorry. Okay, 3.2. Let's go ahead and let's look at the next one, right? We're going to do 12.96 minus 7.2, right? First differences mean that we're subtracting the previous data point from the data point that we are looking at. So 12.96 minus 7.2, this is going to give me 5.76. Okay, and then finally we got 23.328 minus 12.96. Let's see what that gives us. We got 23.396 minus 12.96. And this gives us 10.436. So what does this tell us? Well, if the first differences are not the same, then we should already be able to rule out arithmetic and linear, right? If the first differences had been constant, those would have been our answers. So let's check and make sure the successive ratios are constant, because that is what should be happening since the first differences were not constant. All right, let's see here. Successive ratios mean we're dividing. So what's 6.2 divided by 4? Well, let's check. So 7.2 divided by 4 is giving me 1.8. All right, let's check the next one. We're going to do 12.96 divided by 7.2. And what do we get? We get, okay, 1.8, so it's looking good for exponential. And just the last one to check, we're going to divide by 12.96. All right, 23.328 divided by 12.96. And we get, hopefully, 1.8. Yes, all right, we get 1.8. All right, so because our successive ratios were constant, this is how we answer all the questions to the right. All right, so what type of sequence does the table represent? Well, it's not arithmetic because it's not going up by a certain number each time, which means it must be geometric. And remember, you kind of got like an answer bank right here when you're answering these questions. What type of graph does this data represent? Well, geometric data is going to be always exponential. All right, so geometric, exponential. How do you know? Okay, this part you do need to be able to answer. We're going to say constant successive ratios. All right, write the recursive rule and make sure to include all parts. Here's the part where you guys feel like you struggle a little bit. Recursive rule means that you have to have the previous number determining the number that you're on. All right, so the way that I like to do mine, and there are a couple of ways you could possibly do this, is, okay, I like to start with a sub n, so the term that we're on is equal to the previous term, so a times n minus 1. Since it's exponential, it's going to be times something. Okay, well, what were we multiplying by each time? Well, that's this number right here, this number that we found to be constant every time. So that's going to be 1.8. All right, now make sure to include all parts. Here's what that means. You need to tell me the initial amount. So a sub 0, the initial amount was 4, and n is equal to something. Now this one depends on how you wrote your rule. Since I used n minus 1, I have to start with 1. If I put a 0 right here, 0 minus 1 will give me a negative, and that is not okay. So because I used n minus 1, I have to start n at 1. So 0, 1, 2, dot, dot, dot. There you go. So all three parts, the formula, the initial amounts, and the n values. Okay? Write the explicit function rule. Well, this rule is maybe a little bit easier. This does not require some of these. You don't have to use this special notation either. The explicit function is written like this. We say a sub n is equal to, the initial amount actually goes in the formula here, so that's going to be 4, right? 4 times 1.8, right? The constant is in both. And this time we just say to the power of n. We don't need this because the initial amount is part of the formula, but we do need to say where n starts. And this time we are allowed to use 0, right? Because I can put a 0 right here for n, and anything to the power of 0 is 1, so that still works. All right, and we can say 0, 1, 2, dot, dot, dot. Okay. All right. That is a lot, you guys. I believe this whole table is worth 15 points, 15 points of your grade. The next table is very similar. If I were you, I would pause the video right now. I would try to attempt this table by myself based on the last example. Obviously, though, I don't know if you're going to do that or not, so that's what I would do. All right, let's go ahead and let's take a look. We're going to calculate the first differences. These ones I can do in my head. Hopefully, I won't screw them up this time. All right, 27 minus 29 is going to be negative 2. All right, 25 minus 27 is going to be negative 2. And 23 minus 25 is going to be negative 2. Well, if my first differences are the same, I don't really even need to do this. I mean, you totally can if you want, but if the first differences are constant, then we know that the graph is arithmetic and also linear. Okay, those two things we now know. So what type of sequence does the table represent? Arithmetic. And the graph is linear. How do you know? We're going to say constant. Remember last time we said constant successive ratios? This time we say constant first differences. First diffs, all right? Write the recursive rule. So just like the previous example, I'm going to say a sub n is equal to a sub n minus 1. Again, this means the term we're on is equal to the previous term. And then how did I get from one term to the next? How do I get from 29 to 27 to 25? What am I doing each of those times? I'm subtracting 2. And the last one we did a multiplying because it was exponential. Now we're just going to do minus 2 because it's linear. Don't forget this part where a sub 0, the first term, sorry, the initial term, the 0th term was 29. Oops. And n is equal to 1, 2, dot, dot, dot. Okay, again, because I used n minus 1, the smallest n value I can use is 1. We cannot allow the subscript to become negative. All three parts again in this one, we have the formula, we have the initial amount, and we have the n values. Okay, write the explicit function rule. This one is really similar to how you would normally write, like a y equals mx plus b, but if y'all actually write y equals mx plus b in that form, you're going to get points taken off. I need you to have a sub n is equal to the slope this time, if you want to think of it that way. Your first differences, right, we're going down by negative 2 each time, so negative 2n. And then your initial amount was 29, so we're going to say plus 29. All right, again, we need to say where n equals, in this case, we can start with 0, because I didn't use n minus 1. Okay. All right, that's another 15 points right there, guys. One of those tables was geometric and one of those tables was arithmetic. You just need to be able to figure out the rest. Problem number 4, we're actually given a recursive formula. Tells us the formula, tells us the initial amount is 0 and the n values to use. This is kind of a good hint for the tables, right? Since we used n minus 1, we should be using 1, 2, 3. It's a good example. We are supposed to find t of 7, 7th term, t sub 7, 7th term. The easiest way to do this, since we don't really have a formula we would typically use, is just to make a quick table, you guys. Just to make a quick table. We say n, and we're going to say t sub n, right, the term we're on. And I need to go all the way to 7. So I'm going to say 0, 1, 2, 3, 4, 5, 6, 7. All right. So in my example, I'm taking the previous term times 2. The previous term times 2. And it's important to know that they tell us the initial amount is 4. All right, well, if my formula is telling me to take the previous number times negative 2, I'm just going to do that. 4 times negative 2 is negative 8. All right, 4 times negative 2 is negative 8. And then negative 8 times negative 2 is positive 16, right? You can always double check this in your calculator. Positive 16. The next one's going to be a negative 32, right? Because we're multiplying by negative 2. Negative 32 times negative 2 is going to be a positive 64. And then we're going to multiply by another negative 2, and we get negative 128. All right, the next one's going to be positive 256. And then finally we get negative 512. And if you guys notice on my calculator screen, once I got the pattern going, I just clicked enter every time, which made it super quick. So the seventh term was negative 512. Okay, will t sub 8 be positive or negative? That just means the next term is going to be positive or negative. Well, since it's alternating every time because we're multiplying by a negative, the next one will be positive. If you don't believe me, click enter one more time, and you get a positive number. All right, that's the end of problem 4. Let's look at problem 5. This problem is similar to what we did with the bouncing balls in class. We're kind of looking at rebound percentages. We want to calculate the rebound rate for whatever ball it is that's being analyzed here in this data. And we look at this because we are getting an exponential loss in height. It's a geometric formula, which means we're going to be dividing our bounce heights. Okay, so we're going to do rebound percentage. We're going to do 62 divided by 80, which we get 0.775. All right, the next one we're going to do 50 divided by 62, and we get 0.80645, so I'm just going to say 0.806. Okay, the next one we got 36 divided by 50. 36 divided by 50, which is 0.72. All right, then we've got 27 divided by 36. And you guys do need to actually calculate each one of these numbers. All right, we're getting 0.75. And then finally 21 divided by 27, which is 0.778. All right, so that took me just a minute here. And what we got to do with this is we have to find the average rebound percentage. So we're going to take these numbers, we're going to add them up and divide by 5. All right, so we have 0.775 plus 0.806 plus 0.72 plus 0.75 plus 0.778. All right, got our total, and then since there were 5 numbers, we're dividing by 5 for our average, and we get 0.7658. So 0.7, right here, 0.7658. So the rebound percentage, if we're writing it as a percentage, needs to be 76.58%. All right, that's part of your answer here. Finally, what is the explicit function rule? Remember, this does not require the n-1 stuff. This is just knowing that when it's explicit, it's the initial amount, so 80 centimeters, times your multiplier to the power of n. So what were we multiplying by each time? Well, we multiplied by slightly different numbers each time because this is actual real-world data. So we got to use this average that we found. All right, we got to use this average that we found. So in the parentheses here, in your formula, you need to use whatever that average is, 0.7658. All right? Yes, you also have to tell us where n is equal to 1, sorry, not 1. Remember we started with 0 in that table? So 0, 1, 2, whatever. You can start with 0 as long as we don't have n-1, which we did not have anywhere in this problem. All right, that is problem 5. Let's move on to problem 6. So problem 6 is something we haven't done an explicit example of in class. but it is just an exponential function that you should kind of be able to figure out here. Recently, John Lucky Pants found he is a distant relative of John D. Rockefeller. When Rockefeller died in 1937, he left $10,000 in his will, which now belongs to Lucky Pants. The money has been in a savings account at the Old Dominion Bank, where it has been earning interest at 4% 4% per year compounded annually. Y'all, don't worry about this, seriously. Okay? How much does Lucky Pants have this year? So we're going to write a formula here. All right, it's exponential because we're multiplying each year. We're earning 4% each year. And so here we go. We start with the initial amount, which was $10,000. You got to figure out what we're multiplying by to the power of n. So honestly, you guys just, if you can figure out this number, like you're good to go. All right? So what we're going to do here is we're going to kind of look at this thing as, all right, well, if I'm earning 4% each year, what do I put in the parentheses here? If you put 0.04, your number is going to get really small. Well, first of all, how much time has passed? Let's see, 1937. So it's 2018. We're going to subtract 1937. How many years have passed? I don't feel like doing that math in my head, so we get 81 years. All right, so I actually know n is going to be 81. If I just put in 0.04, look what happens. I get 10,000 times 0.04 to the power of 81, and it just tells me 0 because the number is so small, I assume. Do I have my float on? No? All right. Okay, so it's just telling me 0. Like the number is so small, it's telling me 0. We cannot just use 0.04. Remember, if we wanted the number to increase, we have to use that 1 in the front, right? Because it's taking the money that was in there, the $10,000 plus some. So that 1 stands for 100%. 100% of the money plus 4% growth. So 1.04. All right, this number we're going to want to plug in. So let's fix the one we just did. We just need a 1 right in front of there. And this should give us the correct answer here. And we get $239,717. So 239 717.9103. But you guys, it's money, so just 2 decimal places. We get 239 717.91. So the biggest takeaway for this problem is don't forget the 1 on your percentage, on your decimal. Figure out the year just by subtracting 2018 minus whatever the year is in the problem. All right? That's problem 6. Problem 7 is really similar to problem 4, right? Problem 4 where we made a table. Problem 7, we've got a new formula. We've got an initial amount, and we've got n values. Do you guys notice that since here there's no n minus 1, we started with 0 for our n's? Again, that's kind of another built-in clue on the test. All right, what is t of 8? Well, make a little table, n versus t sub n. Starting with 0, we got to go all the way to 8 this time. 3, 4, 5, 6, 7, 8. Here we go. All right, the initial amount was given to us. It is negative 11. And what am I doing each time? Well, looks like we're adding 28 each time, right? The next term is the term we're on plus 28. So we're going to add 28 each time. So let's start with negative 11 plus 28. And we get 17. All right, so for my next term, I'm just going to add another 28, right? Because we're adding 28 each time. And I get 45. I'm just going to keep clicking enter now to make it quick. We got 73. And then we got 101 and 129, 157, and our 8th term is 185. So t sub 8 is 185. Now this says, will t sub 8 be positive or negative? That's supposed to be a 9. Just the next term, right? So will the next term be positive or negative? Well, all these numbers are negative. Sorry, positive. So our next term is also going to be positive. All right, take a look at the last one. Yay! The average Uber Select car charges an initial fee of $4.02 plus $2.17 per mile driven. That's true, actually. So if you're driving with an Uber, maybe get a cheaper one. All right. Create a simple scatter plot of cost compared to miles driven. Show numbers on the vertical axis. This is something we're actually going to be looking for. Notice that the x-axis is given to you, the scale, but you need to figure out what to go by on the left axis. This is not going to get you full credit, guys. All right? You need to actually build a scatter plot here. I think the easiest way to do this, the way that I would do this if this was me taking a test, is I would make a little chart here. Not of x and y, but, the formula here would just be the initial amount, which is 4.02, plus we're adding 217 per mile, so I'm going to use an n. Like, this would be my formula. We're going to write a recursive rule here in a second, but I'm going to use this because I want to use my calculator table. All right, or you can just make a table like we did in problems 4 and problem 7. Right, our initial amount is 4.02, and we're adding this much every time. So the first one is going to be 4.02 plus 2.17, which is $6.19. Okay, the second one is going to be $8.36. All right. The third one will be $10.53. The fourth one will be 12.7. Oops, sorry. That needs to just be a 4. 12.7. 14.87. And I'm going to go all the way to 12 just because that's what my graph has. So here's a new table. All right, 14.87, the next one is 17.04. The next one is 19.21. Then we've got 21.38 and 23.55, 25.72, 27.89, and 30.06. Now I made my table first so I could figure out what to count by over here. Let's see here. I go from $4 is my lowest number to $30 is my highest number. So I think I'm going to count by kind of fives here. All right, I'm just going to count by fives. I'm going to do this the most evenly that I can. Ugh, I'm trying to zoom in. There we go. So I'm going to say 5. 10, 15, 20, 25, 30. All right, that's a pretty good fit. That's a pretty even looking scale. All right, now we're going to plot the points. You guys don't have to plot all of these points. I think I'll just plot what we have for the x-axis here. All right, it's a simple scatter plot, right? You don't have to do every single point. So I'm going to plot the 0th point, 0 at 4.02. So we're going to have a point right under this 5, right, 0.402. 2 is 8.36, so just below the 10. Okay. And we've got 4 is 12.7. There we go. 6 is 17.04. Maybe right about there. 8 is 21.38. Maybe right there. Let's see, 10 is 25.72. And let's see, 12 is 30.06. So right about there. All right. If I see all this work with a decent looking scatter plot, you guys are getting full credit, all right? Just give me something that I can tell you know what you're doing. Probably the most important part here is this part where we write a recursive rule. So notice, is really important. Notice that we have been given n plus 1. So if they use n plus 1 on the left side, this means the next term. Well, if I want the next term, I got to take the term that I'm on. So I didn't write the minus 1, right, guys? The term that I'm on, and then what? How did I get from this term to the next term to the next term? Well, I just added 2.17 each time. You don't need 4.02 in the recursive rule. You do need to tell me the initial amount is 4.02, and you do need to tell me that n equals what? Well, since we don't have n minus 1, we can start with 0. All right, so those are the 3 parts that I need for that final answer. You got the rule, and you got the initial amount, and your n values. Okay? All right, you guys, you can watch this video as many times as necessary before tomorrow. You can ask me questions. If you want to talk to me Friday morning, I'm in the library before school starts, but email me, whatever you need to do, watch the video again. These same types of questions will be your test on Friday. Good luck.